All right, Leah, I'm going to give you as many hints as I possibly can to get you started in the right direction with this problem. And so it says, prove that an orthogonal 2 by 2 matrix must have the form blah, 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 blah. And so you can't start with that form. That's the end. So what you want to do is you want to start with let A be an orthogonal two by two matrix. Because that's your given, right? You're given that A is 2 by 2 and that it's orthogonal, and you need that. And in the end, you need to show the other pieces. Okay, so let's just let A be just some random 2 by 2 orthogonal matrix. Now it helps if you label it like this because it's sort of in line with their numbering. But remember that this is any A. It's just some random 2 by 2 has this form. A, B, C, and D could be anything. Could be all zeros, whatever. And you want to show that AB is a unit vector. Or sorry, you want to show that there you go. So what do you want to show? And this is the think bubble, right? Before you start any kind of, this is really a proof. Well, it's a proof, but it's a working proof, so it's not a problem. What you want to show is that C equals plus or minus A, and that D equals plus or minus B. Right? Nope. I'm looking at this backwards. Come on. You want C to be plus or minus B, and you want D to be plus or minus A. All right, that's better, right? That's what we want. And if you just keep thinking in these bubbles for a little while, what this really says is you want C squared to equal B squared and D squared to equal A squared. And this becomes important in a minute. All right. So, what does it mean to be orthogonal? One, the length of each column vector is 1. If you square root and square, you get a 1, right? So A squared plus B squared equals 1, and 2. C squared plus C squared, 1. So this is something that's true about orthogonal matrices. And here's the other piece. That the vector AB dotted with CD equals 0, which says that AC minus BD equals 0. All right, so 1, 2, and 3, these are just facts that we've gleaned from knowing that the matrix A that we started with is orthogonal. Okay. All right. What else does it mean to be orthogonal? Orthogonal says that A inverse equals A transpose. That was one of the facts that I put in that last video and said you needed this for homework. And that was the big hint here. Okay. So what we know is that I2 equals A times A inverse, right? Because we have a invertible matrix A. Orthogonal means invertible. And this is equal to A times A transpose, since A is orthogonal. Okay, so now we have 1, 0, 0, 1 equals A, which is A, B, C, D. times A transpose, which is AC BD. And this becomes A squared plus C squared. AB plus CD. And then you have hold on. BA plus CD, right? So AB plus CD, and you have B squared plus D squared. Okay. So this is the last hint I'm giving, because I've almost given the entire problem away. This says that A squared plus C squared equals 1. B squared plus D squared equals 1. AB plus DC equals 0. And then you have these ones above here. So 3 says AC minus BD equals 0. 2 says C squared plus D squared equals 0. Sorry, 1. And lastly, A squared plus B squared equals 1. And again, what you want to show is that this is true. And when you get that, you get this, and then the solution falls out from there. And if I literally give you one more step, I've done the entire problem for you. So I'm going to stop there, and hopefully you can fill in the blanks. If not, email me. I'll be up for a while.